Special effects in animated films breathe life into characters and scenes that are completely imaginary. It usually takes a mix of different effects to give the fantasy a realistic texture. From miniature scale models to computer-generated imagery, it's all about the big picture. 3D animation and photographic tricks make this miniature village loom large on the big screen. It all starts at the drawing board. An artist sketches the various components of the fantasy village. Once he gets it down on paper, the rest of the crew can build it. Using one of the sketches as a reference, a sculptor carves foam into sections of a roof, and he glues the pieces together. This foam roof will then be used to make a mold. The mold maker builds a box around the roof, which is now gray-colored due to the application of a non-stick substance. He pours liquid silicone rubber onto the foam roof in the box. After 12 hours, they pull apart the box and remove the foam to reveal the mold. This mold will be used to cast multiple roof parts for the mini film set. They mix a 2-part urethane solution and pour it into the mold. A chemical reaction causes the urethane to solidify, and as it does, it takes the shape of the mold with all the details. After half an hour, he extracts the cured urethane from the mold. It's a perfect copy of the original roof carving. They mold various roofs for visual interest. The crew then paints all the molded parts of the mini village set in colors that are true to life. The palette has been selected beforehand, but if it doesn't look right to the eye, adjustments can be made. For larger scale structures, a technician arranges reflective dots in a grid pattern. These dots serve as reference points to laser scan the image of the house into a computer. The technician transfers the image a section at a time. Once the image has been loaded into the computer, animators can really play around with it. They can insert digital characters or impose a digital image over a filmed one to cast a shadow. Meanwhile, another member of the crew plants molded trees onto hills of plastic and shapes the landscape of the set. The trees and vegetation are very small scale because the landscape will be in the background. In the world of digital animation, clumps of moss can mimic shrubs, and a hot glue gun is an indispensable tool. Once buildings have been inserted in the set, the crew brings up the lights and checks the effect. They add props and sometimes take others away to improve the look of each scene. Technicians tweak the lighting, which can add visual depth and credibility to any scene. But it's even more critical with a small-scale vista. Little rectangular mirrors attached to the lights allow for minute adjustments. The director of photography operates the camera remotely. Adjustments to the shot's frame or depth of field can trick the eye and make miniatures seem much larger. The computer records the camera movements so they can be repeated at any time. Later, water will be digitally added to this riverbed. Coming up next, animated characters enter the scene with the help of computer-generated tricks. Today, virtual beings are a Hollywood phenomenon. Computer effects have rocketed 3D animated characters into superstardom. But even for digital creatures, fame doesn't come easy. It takes years of work and a large crew of skilled professionals to make them look good on the big screen. It all starts with a good old-fashioned sketch pad. Once the character is defined on paper, the artist sculpts him with clay. Then the high-tech wizardry begins as they laser scan the 3D character from all angles and load the image into the computer. Once he's been captured, the computer artist wraps the character in a digital wireframe. He manipulates the wire mesh to make the character move and breathe. After he creates a dozen or more facial expressions, this machine makes hard copies of those many faces. It repeatedly deposits layers of plastic to build up a physical version of the image. They insert eyes in the sockets, then give these washed-out plastic faces some color. An artist paints each one of the faces along the same lines. Continuity is critical because the faces will be filmed and the images edited together to create the illusion of movement. It's a traditional animation technique called stop motion, and these plastic models are called puppets. Next, a seamstress builds a suit of clothes for one of the puppets. He has to look great because he'll be used to promote the character to merchandisers who might market him as a toy. They scan the fabric and wrap it around the digital character to give him the same outfit. Then add creases for a more realistic texture. The crew lights the mini set for one of the character's big scenes and plans the camera moves. It's a kind of dress rehearsal. One of the puppets acts as a stand-in for the animated character. They move him around in a process called rough placement. It's a critical step which ensures that everyone is in sync: cinematographers, lighting artists, and animators. Seeing the puppet in the room will help animators place his digital counterpart in the various visuals. They literally cover all the angles and leave nothing to chance. Now, the physical merges with the virtual in a special effects trick called human motion capture. A man walks around in a special suit covered with reflective dots. The computer recognizes the dots to transfer the man's movements to a version of the digital character instantaneously. The computer artist uses those captured movements to manipulate the character and insert him into the scene. The effect is one of a digital character who moves just like a human being. They layer digitized images of the set and blend them seamlessly into a single image. This digital layering is called compositing. It allows animators to accurately place the character in the scene. The blend of high-tech special effects with traditional animation techniques gives the best of both worlds. Combined, all these special effects tricks can generate 3D characters with star quality. They are virtual puppets, and the animators are the puppeteers. And on the big screen, the fantasy has never looked so real.
Stainless steel was invented in the early part of the 20th century. The key ingredient is chrome, which forms a protective oxide film on the surface. Originally called non-rusting steel, it amazed consumers because it didn't need to be polished. And today, the concept hasn't lost its luster. Stainless steel is made to look shiny and new, even though it starts from scrap. Old stainless steel is recycled to make new, giving trashed sinks, pots, and other refuse a new lease on life. Tons of scrap steel are fed into a roaring furnace, along with chrome and nickel alloys for added strength and rust-proofing. Enormous electrodes heat the mix to the melting point, creating a dramatic fireworks display in the process. After several hours, the molten mix goes into a refining furnace. Pipes blast in argon gas and oxygen, converting some impurities to gas, and causing others to float to the surface for easy removal. A technician regularly checks the temperature and takes samples to make sure the chemistry is right. A bit more scrap is added to bulk up the mixture as it melts. The scrap also causes a chemical reaction that helps to fuel the refiner. The bubbling steel soup now flows out of the refining furnace. Rollers guide it as it's cast into a long mold. The result is a 75-yard-long ribbon of steel. Torches cut it into shorter chunks called slabs. A worker writes identification information on each one using chalk designed for hot surfaces. Then, the slabs are hoisted over to another station to await further processing. After this break in production, the slabs are reheated to soften them up for more processing. By now, a rusty scale has accumulated on the steel surface. Workers pressure wash it away without cooling the hot metal. The slab shoots back and forth through a machine with rollers. A constant spray cools the rollers as they stretch the steel longer and thinner. It's now over 650 yards long, the length of a couple of city blocks. A spray of water cools the stretched steel a little, but not too much, because it needs to be soft and flexible enough for coiling. This spool coils the strip tightly like a roll of toilet paper. Then, the roll is transferred to another station. Here, the steel goes into a hot acid wash that removes the scale that's built up since the last cleaning. Burners in this machine also heat the steel, then slowly cool it. This relieves stress in the metal, softening it for further processing. The steel is now unwound into a machine that rolls it to the customer's specified thickness. Rolling the metal when it's cold also hardens it and closes its surface pores, making it shine. After one last cleaning, the stainless steel strips are gleaming, and the chrome in this steel combines with oxygen in the atmosphere to form that rust-preventing oxide film. Finally, rotating knives trim the edges and slit the steel to various widths, again to meet customer specifications. This job is now done, and it's a brilliant finish indeed.
When does forging not involve fraud? When you're talking about metal. Many industrial machines contain steel parts that have to withstand great stress. The metalworking method that produces the strongest steel parts is forging, heating the metal, then forming it to the required size and shape. Steel forgings are made from scrap iron. Pieces of used iron recovered from demolished buildings and old cars, as well as bits of new iron left over from the manufacture of iron products. Forge workers maneuver a gigantic magnet to lift almost 6 tons of scrap at a time until they filled a 28-ton scrap bucket. The bucket empties 2 such loads into a fiery furnace whose temperature peaks at 3,000 degrees Fahrenheit. This is called an electric arc furnace because the heat is created by a strong electric current running in an arc between 3 electrodes. There are about 20 main grades and 100 subgrades of steel. They're produced by adding specific metals or non-metallic chemical elements such as aluminum, nickel, chromium, vanadium, manganese, carbon, and molybdenum. They also add the mineral fluorite to help fuse the metals, some of which are in the form of blocks called ingots. Throughout the 3.5-hour meltdown, they test and adjust the chemical composition. They try to attain the lowest hydrogen, oxygen, nitrogen, and sulfur levels, the key to producing strong, high-quality steel. Then they pour the sizzling molten metal into a 50-ton ladle that's lined with heat-resistant brick. They add aluminum and lime to chemically counteract oxidation, rusting caused by air exposure. Now they cast an ingot, a block of steel that they'll shape into a forging. The molten metal flows out the bottom of the ladle into a mold below. This bottom pouring, as it's called, makes for a smoother casting because liquid flowing downward doesn't swirl around as much as liquid poured sideways. This forge can cast ingots weighing up to 46 tons. After several hours, the ingot solidifies, and they turn the mold upside down to extract it. Then, over 12 hours, they reheat the ingot to 2,200 degrees Fahrenheit. This makes it soft enough to hammer or press into shape. To make large forgings, they use a machine called a forging press, mounted inside a forming die or a pair of dies, depending on the technique they're using. The press applies thousands of tons of pressure, crushing the ingot and forcing it against the die. The steel is quickly oxidizing with all this air exposure. They use a high-pressure water gun to remove the scales of rust. An ingot often passes through a die several times or through a series of dies arranged in sequence. Each pressing forms the metal bit by bit into the final shape. Metal is composed of microscopic crystals. Squeezing it in a press bends these crystals, destabilizing the metal structure. But reheating the metal creates new crystals to replace the deformed ones. This restabilizes the structure, and because the new crystals are smaller, makes the metal stronger than before. That's why finished forgings require heat treatment in what's called an annealing furnace. They heat for a day or two depending on the grade of steel. Then they soak in a water and chemical bath for about 5 hours. This strengthens the steel even more. Finally, workers mount the steel forgings on lathes and milling machines. They remove the rust scales that form during heat treatment, then precision machine the forgings into what the client ordered. Usually industrial parts such as rotors, spindles, and shafts. Many factories prefer to buy forgings in the shape of blocks or bars and machine the parts themselves. Throughout history, wigs were status symbols, hence the term bigwig. One early wig-making technique was to use goat skin to simulate a scalp, and then hook hair into it with an embroidery needle. Today, animal skin is no longer used. These days, wigs can look so real that no one would notice. To make a custom wig, a wig master measures the client's head from all angles because heads come in many shapes and sizes. He wraps her head in cellophane, twisting it just under the earlobes. Next, he sticks filament tape all over the cellophane wrap. He layers it 4 times to make a cast. He lifts the tape and cellophane cast from her head and places it on a wig block, a head shape made of canvas or wood. Using a grease pencil, he traces around the cast, making a pattern of the client's hairline on the wig block. The wig master then cuts pieces of plain blue paper. He pins it on the wig block within the pattern lines. The paper will prevent light from reflecting into his eyes as he works. Now he places a large-sized polyester and cotton lace on the block and cuts it to the penciled outline. He pins a finer lace from front to back, pleating the edges with pins. He pulls open a drawer full of real and fake hair, and it's hard to tell the difference between them. He chooses a tail of synthetic hair labeled Venetian blonde. Pieces of pink and orange synthetic hair will be blended into the Venetian blonde tresses to create dramatic highlights. This is the tool for the job. It's a giant comb with rows of sharp steel teeth. It's called a hackle. The wig master places the Venetian blonde synthetic hair between the teeth of the hackle and sets the bright pink and orange locks on top. Now he repeatedly drags the hair through the hackle. He loses some strands in the comb, but those are usually the weaker ones. This is called hackling, and the action gets progressively more vigorous. He twists and twirls the tail as he pulls it through the hackle. This is actually dangerous work. One wrong move and he could pierce his hand on the barbed comb. Once the hair is blended, he cuts it in 2. Then he presses the hair into little metal pins on a leather holding card. The pins on a top card interlock with the bottom one. He pulls hair out of the holding cards a few strands at a time. With a small needle that looks like a fishing hook, he knots the strands into the lace, beginning at the nape. This is called ventilating. It's very similar to rug hooking. In fact, it may be why toupees are often referred to as rugs. Ventilating is labor-intensive. He spends a minimum of 50 hours knotting the thousands of strands that it takes to make a wig. Partway into the job, he combs out any tangles and flounces the hair to make sure it moves naturally. Wigs for film and TV are usually made by hand rather than machine because the result is more authentic looking. Because the camera tells all, the wigs need to look as real as possible. He weaves the front of the wig 1 strand at a time because the front hairline always gets the most scrutiny. Now it's time for the fitting and the transformation. The wig needs a little styling, and he trims the ends. He cuts away the extra lace, and voila! She's ready to let her synthetic hair down and get into her new role. As anyone who's shivered through a cold winter knows, You've got your run-of-the-mill winter jackets, and then those really warm winter jackets that can run up to $1,000. The difference is what they're made of and how they're made. A top-of-the-line winter jacket gives you the warmth without the weight. It's waterproof and comfortable. No bulky stuffing or constrictive styling. The designer draws a pattern by computer. A software program then adapts the pattern to different sizes. A giant printer puts it to paper. The tailor spreads out several layers of each of the fabrics that'll make up the jacket. He lays out the pattern, then pins it in place. Next, he cuts through several layers of fabric at a time with electric scissors. These scissors maneuver much like a jigsaw around the lines and curves of the pattern pieces. The finished jacket will actually be made up of two jackets sewn together, an insulation jacket on the inside and a windbreaker on the outside. The inner insulation jacket begins with a nylon lining. Then they layer the key components, a film to stabilize and protect the insulation, then the thick polyester insulation itself. At this point, the insulation layer is larger than the lining. This ensures that every inch of the jacket will have insulation. Working with one piece at a time, they stitch the layers together. Each line of stitching is tacked at the beginning and at the end for added strength. They cut off the excess insulation, then sew an overlock around each piece to hold the remaining insulation solidly in place. Once they've completed each piece of the insulation jacket, they sew it all together. Next step, the windbreaker. The outer fabric is heavy nylon. The lining is a special fabric with tiny holes, large enough to let humidity escape, but small enough to stop water droplets and wind from penetrating. This is what will allow the jacket to breathe, while at the same time making it windproof and waterproof. Finally, it's time to put the two jacket components together. Using two separate strong threads, they sew seams made of knotted stitches. No seams go through the jacket because that would break the insulation barrier and let in cold air. They join the two jackets together only where they have to, at the collar, the cuffs, the hem, and along the zipper. And this isn't any ordinary zipper. It's made of corrosion-resistant nylon, with a nickel-plated slider that lasts 7 times longer than a normal slider. Until now, they've been sewing the jacket turned inside out. Now they turn it right side in for finishing. These heavy-duty snaps have sturdy grips that anchor themselves between the fibers in the material so they won't tear the fabric with repeated use. Some jackets have decorative embroidery. Designers use a computer program to prepare the pattern. The automatic machine embroiders 5 jackets at once. This intricate owl pattern takes 1¼ hours to complete. The final result is a stylish jacket whose secret weapon is that hidden layer of insulation. It traps air inside your body, then heats it up, creating a cushion of warmth against the cold of winter. For centuries, hunters have used wooden ducks to lure live ones to within shooting range. Stringing together decoys and floating them in the water, hunters trick the birds down from the sky with duck calls. Nowadays, hunters generally prefer cheaper plastic decoys. Wooden ducks are mostly decorative items for the home. This company's flock includes males, females, and androgynous models like this one. This more elaborate male is inspired by another aquatic bird, the loon. To make them, these craftsmen use eastern white pine because it's easy to carve and has a nice grain. First, a machine shapes a 2-inch thick slab. They cut the slab lengthwise. They'll use 4 to 6 of these smaller pieces to make most of the duck's body. The birds range in size from baby ducks just 4 inches long to geese at more than 19 inches long. A craftsman now applies a generous amount of carpenter's glue to one side of the wood. Using a lot ensures a strong bond and prevents splitting later on. The pieces then go into what's called a wood clamp. He tightens a vise, squeezing them together. It takes about 2 hours for the pieces to bond properly. Then he'll shave away the excess glue and even up the surfaces. Once that's done, they run the block over what's called a joiner. A roller with 3 blades shaves about 3/4 of an inch from what will become the top and bottom of the duck. Each model has 3 wooden patterns, for the top, the bottom, and the profile. Here, a worker traces the outline of the bird's profile in pencil on the wood. Since this is a small model, he'll make 2 birds with 1 block. Using a bandsaw, he trims along the trace line. This company recycles the cutoffs into fireplace kindling and shavings for farm stables. Next, he uses another pattern to create the top of the bird. These patterns provide only the general shape of a particular model. The craftsman will later carve the details using smaller electric tools and by hand. Now he sands the wood with a pneumatic drum sander, a tube of pressurized air with sandpaper stretched over it. He uses higher pressure for sharper curves, lower pressure for softer edges. To sculpt the bird's plumage, the craftsman uses this band sander whose rounded edge presses sandpaper into the wood. Here he makes 3 long grooves, one on top and one on each side of the duck. The head's made from a different piece of wood than the body. Here he sands down the piece to smooth out the curves. Using various shaping tools and the band sander, he sculpts the bird's head and bill area, then the underside and rear end of this waddling duck. He also carves depressions for eye sockets to come later. Here he puts glue on the neck to attach it to the rest of the body. Using a nail gun, he reinforces the area with 2 nails on each side. To hide the nails and smooth out the neck, the craftsman uses wood putty. Once it dries, he'll sand it smooth. Next, he tints the duckbill using an orange wood stain. Then a forest green stain to tint the head and neck areas. Males have colorful feathers to better attract mates. Females have more neutral colors to blend into their surroundings and protect their ducklings. The craftsman covers the duck's lower body with a clear wood stain. This way, the natural grain of the wood shows through. The front gets a clear but darker stain to mark the chest. And darker stain also highlights the plumage and the long grooves. Then some green accents for the feathers on the sides and the back. Next, 2 coats of white paint to mark the duck's collar. Then he glues plastic eyes in the eye sockets. The irises are black, brown, or red depending on the model. He then sprays on a protective water-based varnish and elevates the duck on nails so that the underside will dry along with the rest. Finally, the craftsman rubs the entire carving in wood wax. This makes the varnish appear uneven in places, giving the duck a worn antique finish, like he's been around the pond a few times. The price of wooden ducks vary according to size and detail. $500 will buy you this magnificent Canada goose with wings stretched and ready for a graceful landing. What do wool and hand cream have in common? Well, a sheep's fleece has an oily protective coating, which contains a substance called wool grease. When factories make yarn, they first clean the wool with detergents. The grease is processed into lanolin, a common ingredient in hand creams. Historians believe that people began raising sheep for food and clothing about 10,000 years ago. And around 4000 BC, they started spinning the wool into yarn for weaving fabric. The Romans brought wool production to England in about 50 AD. Woolen fabrics would become the country's chief export for centuries. In 1797, Britain shipped 13 sheep to Australia, starting what would become the largest wool industry in the world today. Wool fabric is durable, wrinkle-proof, and holds its shape well. It absorbs moisture and insulates against heat and cold. That's why wool is ideal for clothing like sweaters and coats. Sheep shearers use power shears, removing the fleece in one piece. They discard any stained or inferior wool and then sort the rest according to the quality of the fibers. This grading is based on length, color, waviness, and fineness. The wool is cleaned with detergents before processing. The wool arrives at the factory in compressed bales. Workers untie them and feed the wool into the opening equipment, whose metal tooth rollers comb out and separate the fibers. From there, the fibers go into the blending room, where air currents mix different grades of wool to get the desired texture. If they'll be weaving a wool blend, they mix the wool fibers with other materials such as polyester fibers. A thorough blending takes about an hour. An air pipe transports the blended fibers to the next station. On the way, sprayers lubricate them with a mineral oil mixture to make processing easier. The fibers arrive at the carding machine, where they pass through a series of rollers with thin wire teeth. This untangles the fibers and lines them up parallel to each other. This process also removes any pieces of debris caught in the fibers. The carding process produces a smooth, flat sheet called a web. The equipment divides this web into thin, flat strips. These strips go through rub aprons, two rollers that twirl them into thinner, rounded strips called rovings. The rovings wind onto a spool. Rovings look like yarn, but if you pull on them, they simply tear. They haven't been spun, so they have no strength. Each roving goes into a device called a spinning frame. It stretches the roving and spins it tightly, producing wool yarn. The yarn winds onto a bobbin. Spinning gives the yarn strength. Now they can weave it into wool fabric. A fully automated loom does it all. Watch in slow motion as it inserts one strand at a time, crosswise, through stationary lengthwise strands. It's computer programmed to thread in a specific under-over configuration, according to the type of weave. The loom inserts 400 strands per minute. After weaving, they burn off vegetal matter, such as straw fragments. Then they dye and dry the fabric. All wool fabrics undergo finishing to give them a particular appearance and feel. These spiked rollers created a plush finish. Wool fabrics can also have a sheared or flat finish.